All right, so this is the first of 3 videos on kind of quick graphs for quadratic functions, okay? The quick graphs aren't as quick as the ones for the linear functions, but it'll make graphing quadratics a little bit easier, okay? So there's 3 different forms. In this video, we're going to go over vertex form. In the second video, we'll go over quadratic equations in standard form. And in the third video, we'll go over quadratic equations in intercept form, okay? We're going to find the vertex. We're going to determine the equation of the axis of symmetry. We're going to find the intercepts if they're easy to find. In some cases, they won't be as easy to find. And then we're going to graph the function using that concept of symmetry and this axis of symmetry, okay? We're also going to determine the maximum and the minimum value of the function, okay? So we should know by now quadratics, the graphs are parabolas. It's this U-shaped graph, okay? If the parabola opens up, which means it's truly like a U-shape, then there's going to be a minimum value, okay? This is an absolute minimum value at the vertex here. If the parabola opens down, okay, it's this upside down U-shape here, then we're going to have an absolute maximum value, which is also going to occur at the vertex here, okay? So let's get on to vertex form, all right? So the vertex form of an equation is the following. Y equals some coefficient a times the quantity x minus h to the second power, that's what makes it a quadratic, plus a constant value of k, okay? So a couple things we need to go through. You can pause and read through these bullet points if you want to. I'm just going to highlight a few of those. All right, so if a is positive, the parabola is going to open upward, okay? And the graph will have a minimum value, okay? If a is negative, the parabola is going to open downward, and the graph is going to have a maximum value. All right. Now, the reason this is called vertex form is because you can just look at the equation and pull the vertex of this parabola right from the equation, okay? So h, okay, so we've got, this is minus h, so this h value, okay, is going to be the x-coordinate of the vertex, okay? This constant k is going to be the y-coordinate of the vertex. Okay. Now, if you've already learned how to graph using transformations, you can think about those in terms of horizontal and vertical shifts, okay? So that's going to give us the vertex of the parabola at h comma k, all right? And the axis of symmetry is going to be the vertical line that goes through that vertex, and that equation is going to be x equals that x-coordinate, in this case, h, all right? The y-coordinate of the vertex is always going to be the maximum or minimum value, depending on how the parabola opens, okay? And then you can always find the intercepts. You know how to do that. Substitute 0 in for x to find the y-intercepts. Substitute 0 in for y to find the x-intercepts, okay? Y-intercepts are generally going to be easier to find. Y-intercept singular is going to be easier to find than the x-intercepts, if they have any, okay? And then we can use symmetry to help us graph, okay? So we've got this equation in vertex form, x minus 3 quantity squared minus 5, all right? So let's answer this question. Which way does the parabola open? So a, there is no number there, so it's understood to be a 1, okay? So a equals 1, which means the parabola is going to open up, okay? A is positive, the parabola opens up. Because the parabola opens up, there's going to be a minimum value, and we'll figure out what that is later. Okay, we have to find the vertex first. So to find the vertex, remember our vertex was at h comma k, okay? So our h value, remember this is x minus 3, but that makes the h value 3. And this k, negative 5, remember our k, it's the same value that we see here, so minus 5. So it's the opposite of what you see here and the same as what you see with k. So that's why h is positive 3, and k is negative 5, okay? Once I have those values, then I have my vertex. It's going to be the x-coordinate 3 and the y-coordinate negative 5, okay? If I know the vertex, then I can write my equation of the axis of symmetry, okay? The axis of symmetry is the vertical line that goes through the vertex. Vertical lines have the form of the equation x equals some number, and in this case, x equals 3. So the axis of symmetry is going to be the vertical line through x equals 3, okay? The minimum or maximum value, in this case, it's a minimum because the parabola opens up, okay, is going to be the y-coordinate of the vertex. So the minimum value of the function is -5, and we say that occurs at x equals 3. Okay? So this vertex is the key point that I need to graph this function. All right? Okay, next thing let's do, we're going to find the y-intercept. So we've got our function here. Again, finding the y-intercept is pretty easy. We're just going to substitute 0 in for x. Okay, so I've got y equals 0 minus 3 squared minus 5. Simplify in the parentheses. Exponents here, I'm going to square that -3, which gives me 9 minus 5, which is 4. Okay, so my y-intercept is going to occur at 0, 4. Okay. Remember, I said we're going to do quick graphs here. We could make a table of values and find more ordered pairs, but we really have everything we need right now, okay? Now we're going to move over to the graph, and we're going to graph the function using that concept of symmetry and using this axis of symmetry to kind of help us out, okay? So let's go to the graph. All right, so our graph had a vertex at 3, -5, okay? Our axis of symmetry, remember, was the vertical line that goes through that point. Okay, that was at x equals 3. Okay, we've got our y-intercept that we found. Okay, it was right there at 0, 4. All right, and then we want to use the concept of symmetry. Okay, so notice this point is 3 units to the left of the line. Okay, so we're going to put another point on the other side of the axis of symmetry, 3 units to the right of the line. Okay, so the coordinates for that ordered pair should be 6, 4. So notice the y coordinates the same, okay, and both points are equidistant in terms of their x coordinates from the x coordinate of the vertex. Okay, so they're both 3 units away. So think about back in geometry when you were doing reflections. Okay, those points are reflected about the axis of symmetry. Okay. So we only really need 3 points. Remember, this is a U-shaped graph. If we were to find the x-intercepts, you would see that they're going to be irrational numbers. They're going to be decimals. They're going to be somewhere in between here. Okay, but again, this is a quick graph. So let's go ahead and draw that graph, and we see our parabola should look something like that. Okay, so that's how to use vertex form to make a quick graph of a parabola, a quadratic function.